So today we are going to discuss about the nomenclature of alkanes. So let's begin the video. Nomenclature of alkanes. There are two ways by which alkanes can be named. The first one is their common or trivial names. Previously, these alkanes were named on the basis of their methods of their preparation or the name of the person working on them. Like for example, marsh gas was given to the name given to methane because it was found in marshy areas. Acetic acid got its name from vinegar because in Latin acetum means vinegar. These common or trivial names are mostly used for the isomers, and we use an iso or neo to differentiate between these isomers. Now, isomers are like, for example, if any molecule or any compound has the same molecular formula but different structural formulas, so all those structures would be called its isomers. Like for example, if I say butane, what is the formula of butane? How many carbons are present in butane? There are 4 carbons present in butane and how many hydrogens? 10. And remember that the valency of carbon is 4. That means carbon in all the cases will make 4 bonds, not more or less than 4. See, I have arranged the 4 carbons in a straight line, in a straight chain. And now I will make bonds for hydrogens. Let's count how many hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So see, there are 4 carbons and 10 hydrogens attached to all these 4 carbons, so that each carbon makes 4 bonds. Now this is the structural formula for butane. Now I can make another isomer of butane, like I can reduce the chain. Instead of making a chain of 4 carbons, I can make a chain of 3 carbons and attach the fourth one with the middle carbon. I will not attach this fourth carbon with any of these carbons which are present on the ends, which are also called terminal carbons, because otherwise this carbon, the fourth one, would become a part of that chain. Now see how many hydrogens will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Again, the number of hydrogen for this structure is also 10, but the arrangement is different. So that is why these two are called the isomers of butane, and we can differentiate between them. Like if the carbons are arranged in the form of a straight chain, we call it N butane. And if the arrangement is like this, like there is a chain of carbons and we have another carbon attached as a group, or it's also called a substituent or a group, then, or we call it a branch. If any of the carbon is present in the form of a branch, we call it branched hydrocarbon, and if there is one branch on one carbon atom, then we call it iso. So this is isobutane because there is one branch on the middle carbon atom. Now let's talk about pentane. What's the formula for pentane? It is C5H12. Now let's see how many structural formulas pentane can have. I'm arranging all the carbons in a form of a straight chain. So now we have got 5 carbon atoms, and let's count how many hydrogens will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 hydrogens with 5 carbon atoms. Now we have to make their isomers. We have to make the isomers for isomers of pentane. So for that I can reduce the number of carbons in a chain. For example, I can draw a chain of, instead of 5 carbons I can draw a chain of 4 carbons, and then I will put the fifth one with any of these 2 carbons which are present in the center. Remember, not with the terminal carbons. Alright, now count how many hydrogens would be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So again there are 12 hydrogens. See, the molecular structure is different, but the structure is different, but their molecular formula remains the same. Now let's further reduce the carbon chain to 3 carbons, and the fourth and the fifth carbons will get attached with the carbon which is present in the center. Now let's count hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, in this arrangement also there are 12 hydrogens attached with 5 carbon atoms. Here we have got 3 different structural formulas, but their molecular formula remains the same. So let's name them. This is called N-pentane when the carbons are arranged in the form of a straight chain. The second isomer in which there is one branch on one carbon atom, so that would be called isopentane. And the last one in which there are 2 branches on the same carbon atom, so that would be called neopentane. So that was about their common or the trivial names, and I just told you that one of the carbon can be present as a group, or carbons can be attached with the chain in the form of groups. So these groups are called alkyl groups. And how do we get alkyls? Actually we get alkyl groups from alkane. But how? You know that alkanes, the homologous series of alkanes, the first member is methane, then ethane, propane, butane, and so on. In methane there are 4 hydrogens. Now if any one of the hydrogen is removed, so we will get CH3 group with a bond from which the hydrogen is lost. Ethane is C2H6, and if one of the hydrogen is removed from ethane, then we would get C2H5 group. If one of the hydrogen is removed from propane, so we will get C3H7 group, H7 as propyl group. If one of the hydrogen is lost from butane, then we will be left with C4H9 group. Now these groups that are formed are called alkyl groups. So that means alkyl groups are derived from alkanes when alkanes lose their hydrogens. From methane, we just remove the word an and replace it with yl for an alkyl group. Like from methane, when methane loses one hydrogen, methane changes into methyl group. When ethane loses one hydrogen, it becomes ethyl group. When propane loses one hydrogen, it becomes propyl group. When butane loses one hydrogen, it becomes a butyl group. So that is how we get alkyl groups. So again, how do we get alkyl groups? We get alkyl groups from alkanes when any of the alkane loses its hydrogen atom. Now let's move to IUPAC system for naming alkanes. For this we have to follow certain rules, and let's see what are the rules. So the first one is that we have to select the longest chain of carbon that determines the parent name of the alkane. So how do we get the parent name of the alkane? We get it by selecting the longest possible chain. Like for example, if I make a chain like this, and I make a branch on one of the carbons. Now for hydrogens, I write hydrogens with the carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, so let's let's select the longest possible chain. If I take this as a longest possible chain, so how many carbons will be there? There will be 1, 2, 3, 4, 5, 6 carbons. So I will select this as my longest possible chain. But if I draw a structure like this, like CH3, CH2, 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 CH, CH3, CH2, and CH3. Now in this case, let's see which one would be the longest possible chain. If I count like this, a straight chain like this, 1, 2, 3, 4, 5, 6. So the straight chain consists of 6 carbons. But if I move down, still I count till 5, carbon number 5, and I move down, because a chain is something in which carbons are attached to each other directly, so one carbon after another. So this is carbon number 5, it next would become 6 and 7. Now in this case, my longest possible chain would be this one, not the straight chain, but this one. It would be my longest possible chain, having 7 carbon atoms instead of selecting a chain with 6 carbons. Now let's move on to the second rule. For the second rule is that number the longest chain beginning from the end of the chain nearer the substituent. For this I'm drawing another structure, CH3, CH, CH2, 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 CH, CH3. I'm just drawing the previous chain in which we selected the longest chain of 7 carbon atoms. Now we have to uh, we can number the chain either from left to right or from right to left, but we have to see or we have to first of all check the branch or the substituent. So in this case, this is our substituent, and we have to give it the lowest possible number. So for that, how can this be done? This can be done by counting from the side which is nearer or closer to the substituent. So it would be 1. We'll count from here: 1 2 3 4 5 6 and 7. So that means we'll say that our substituent is attached with carbon number 3. All right. And if I draw, like, I can give another example. If I make a structure like CH3, CH2, CH2, again CH2, CH, then CH3 and CH3. Again, this is the longest possible chain in a straight line, and this one is my substituent. So I will give it the lowest possible number. For that, I will start counting from the other end, from the right hand side. So it will be 1 2 3 4 5 6. So if I had counted from the other side, the number would be like 1 2 3 4 5 6. So instead of taking 5, I will select the lowest number, which is 2 in this case. Third rule is that number the substituents to designate the location of the substituent group. Write the number designating the location of the substituent, then name the substituent followed by the parent name. That means, first of all, we have to number the substituents. And then in the end, we have to write the name of the parent uh, parent chain. So I am writing an example like CH3, CH2, 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 CH, CH3, and here I have CH2 and CH3. Again, I'll start counting from here: 1 2 3 4 5 6 7. So that means the chain is of 7 carbon atoms, and my substituent is attached at carbon number 3. So I will write the number, I will locate the position of the substituent, that it is attached with carbon number 3. So I will write 3 methyl. The name of my substituent is methyl, CH3. It comes from methane, CH4. So this is a methyl group. I will write 3 methyl followed by the name of the parent chain, which is heptane. In this case, chain of 7 carbons is called heptane. And if I draw this structure, this chain, CH3, CH2, CH2, again CH2, CH, CH3 and CH3. So I'll start I'll start counting from the end which is close to my substituent or the branch. So I will count 1, 2, 3, 4, 5 and 6. My substituent is attached with carbon number 2, so I'll first write 2 to locate its position. It's 2, it's attached with carbon number 2. And which group is attached? What's the name of my substituent? Again, it's methyl, 2 methyl, and in the end I'll write the name of my parent chain, which is hexane of 6 carbon atoms. Chain of 6 carbon atoms is called hexane. Now let's move to the next rule, that when two or more substituents are present, give each substituent a number corresponding to its location on the longest chain. Substituents are written in an alphabetical order. Now it is not necessary that the chain has only one substituent. There can be more than one substituents, and the substituents can be even different. Like for example, if I draw a chain CH3, CH, CH2, CH2, CH3, and I make this substituent the methyl group and an ethyl group attached with this carbon CH2, CH3. Now I'll start numbering. Let's count. If I number it from this side, 1, 2, 3, 4, 5, 6. So the numbers that I will get will be 2 and 4. And if I start counting from this side, 1, 2, 3, 4, 5, 6. So the numbers will be 5 and 3, which are greater numbers. So I will not select these numbers to locate my the position of my substituents. So with carbon number 2, I have methyl group attached with the chain, and at carbon number 4, I have ethyl group attached with the chain. Now I have to write these both the names of these both the substituents in an alphabetical order. So which one I would write first, ethyl or methyl? Yes, I would write ethyl first, and ethyl is attached with carbon number 4. So I'll write 4 ethyl, and then I will write the carbon number with which my methyl group is attached, 2 methyl. So we are done with the name of the substituents, and in the end what do? We write the name of the parent chain, which is hexane in this case. So I hope this is clear. So we can move on to the next example, next rule, which is that when two substituents are present on the same carbon atom, then use numbers then use that number twice. Like for example, if I make a chain like CH3, CH2, CH, CH2, CH2, CH3, and I make two branches at this carbon with methyl group attached over here and an ethyl group. Now in this case, uh, I can write C2H5, or I can also write okay, I can write C2H5 over here. So over here you see both methyl and ethyl groups are attached to the same carbon atom, and I'll be counting the chain from this side so that I get the lowest possible number, which is 3 in this case. So what will I do? First of all, I will write the name of ethyl first, so it would be 3 ethyl because ethyl is attached with carbon number 3, 3 ethyl. Then again, uh, we will again write 3 because with carbon number 3 methyl group is also attached to carbon number 3, followed by the name of the parent chain, which is uh, 4, 5, 6, which is what? Hexane in this case. Let's move to the next rule, which is that when two or more substituents are identical, indicate this by using prefixes di, tri, tetra, so on. So we can discuss different examples for this, like if I draw a structure CH3, CH, CH, CH3, and I write a methyl group here and another methyl group over here. So when I'll write the name, I'll number the chain. First of all, the first rule is numbering the chain, selecting and numbering the longest possible chain. So my groups or the branches are at carbon number 2 and carbon number 3. The substituents are attached at carbon number 2 and 3, and both the substituents are identical, they are alike. So I'll just write that with carbon number 2 and 3, two methyl groups are attached. For 2 I will write dimethyl. There are two methyl groups. So for them I will write dimethyl. And what's the name of the parent chain? It is butane. Now let's do another example. I'm drawing I'm making the structure CH, 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 and CH3, CH3, CH3. So there are total 3 substituents, 3 branches on this chain. Um, let's number the chain. First of all, 1, 2, 3, 4, and 5. So that means it's a pentane. And with which carbons the methyl groups are attached to? It's carbon number 2, sorry, carbon number 3, and carbon number 4. So there are total 3 methyl groups attached to the chain. So for 3 I will write trimethyl pentane. Is it clear now? Okay, let's do another example, like CH3, C, carbon, carbon, another methyl group CH3, and CH3, CH3. Here again we will count, we will select the longest possible chain and we'll number it. So here with carbon number 2 and carbon number 3 there are methyl groups. And how many methyl groups are there now? There are 4 methyl groups. 2 are attached with carbon number 2 and rest of the 2 are attached with carbon number 3. So we'll write 2 comma 2 and then 3 comma 3, and now we have 4 methyl groups. So for 4 we will write tetra methyl, and the parent chain is butane. Is it clear now? Rule number 7 is that when two chains of equal length compete for selection as the parent chain, choose the chain with the greater number of substituents. Okay, so let's make a chain of carbons. 1, 2, 3, 4, 5, 6, and 7. And now I am attaching different groups along the chain, like CH3 over here, CH3 over here, and CH2, CH2, CH3. Which group is it? And another CH3. So you are familiar with CH3 groups, which is methyl, and over here this group consists of 3 carbons. So what we will call, what would be the name of that? It's propyl group. So in propane, we have the propane is CH3, CH2, CH3. So when propane loses one of the hydrogen, it becomes propyl group. Now in case of propane, there can be 2 points of attachments. Like with the chain, it can be attached with carbon number 1, or it can be attached with carbon number 2. So if it is attached with carbon number 1, it would be CH2, CH2, CH3. This would be present in this form. And if it is attached with the chain with the central, with the carbon which is present in the center, or carbon number 2, so it would be like this. It would look like this. Carbon number 1 attached with the chain over here. So this one will be, we would call that N-propyl group. This is N-propyl group. And this one is Isopropyl group, when it is attached with the central carbon, or the carbon which is present in the center, or carbon number 2. So again, we'll number the chain. The first thing that we do is we locate and number the lowest possible chain. 3, 4, 5, 6, and 7. That means it's heptane. And let's now write the names of the different groups which are attached to it. So at carbon number 2 we have methyl group, at carbon number 3 we have methyl group, at carbon number 5 we have methyl group. So there are total 3 methyl groups, for which we will write tri methyl. And at carbon number 4 we have what? We have N-propyl. We have N-propyl group, and in the end we have to write the name of the chain, which is heptane in this case. Now eighth rule is that when branches occurs first at equal distance from either end of the longest chain, choose the name that gives the lower number at the first point of difference. That means you have branches on both the ends at equal distances. Like for example, if you have a chain like this, CH3, CH2, no, I write a group, attach a group with it, CH2, CH, CH, and then CH3. This is the longest possible chain, and here we have two groups attached to it at equal distances. These two groups are attached on the chain at equal distances. Like if you count from any of the sides, one of the methyl group will get carbon number 2. But I attach another group over here close to this methyl group. Now it means that we should start numbering from here where more groups are attached. So we should start numbering from the end where more groups are attached to the chain. Like if we count from here, the points of attachments would be carbon number 2, carbon number 3, and carbon number 5. So we have numbers 2, 3, and 5. What if we count from the other side? Like if I count from here 1, 2, 3, 4, 5, 6. Then the numbers with which the methyl groups are attached would be 2, 4, and 5. See, the numbers are greater. 2, 4, and 5. So that means we will not select these numbers. Now we will select 2, 3, and 5, and the name would be trimethyl, followed by the name of the parent chain, which is hexane. So we are finally done with the rules. Let's practice some more. So you can get a question in which you can be given a structure for which you have to write the name. So let's open the rewrite the structure. I'm writing carbon, this one, with which 3 methyl groups are attached to. This one, 3 methyl groups are attached with this carbon atom. Then next we have this one, which is CH2. Then this one, which is CH, and with this there are 2 methyl groups attached to it. According to the rules, we have to select the longest possible chain. So I think the longest possible chain would be 1, 2, 3, 4, 5. This would be our longest possible chain, and we have how many substituents or groups attached to it? 1, 2, and 3. And these substituents are attached with carbon number 2. That means 2 methyl groups are attached to carbon number 2, and the third one is attached with carbon number 4. So we'll name it, like we'll write the numbers first: 2, 2, 4, trimethyl for 3 methyl groups, pentane. Am I right? Next, we have to write the structure for 2,4 isopropyl heptane. Isopropyl heptane. So heptane means you will draw a chain of 7 carbons: 1, 2, 3, 4, 5, 6, 7, and number them: 1, 2, 3, 4, 5, 6, and 7. And now see the groups that are attached to it. The at carbon number 4, sorry, the name is 4 isopropyl. So at carbon number 4 we have isopropyl group. Remember, isopropyl group was this one, in which there are 3 carbons, and the chain is attached with the middle carbon atom. Now you can write hydrogens. So this is it. I hope you have understood all the rules for naming alkanes. So thank you for watching, and don't forget to like, subscribe, comment and share.